Hello, everybody. So hopefully this assignment, I have an assignment for you to do today on Delta Math. It should go okay. It should go pretty well, given the fact that you've watched the videos on Friday and Tuesday. So if you haven't done that, please go to Edpuzzle. They're still there and watch those. So today we're really putting a little bit more paper, pencil to paper, so to speak, and doing some math to determine some characteristics of these sine and cosine functions. So here's your Delta Math assignment, and the first one is just to find the period. The period is the smallest interval in which things repeat. So often we can start when x is 0, and I'm starting at the top of the wave, and I would go down and then up again. As soon as I get here, I start to repeat. I go down and up again. So what is this interval right here? From here to here, what is that interval? That is from 0 to 8 pi. So the period is 8 pi. It takes an 8 pi amount to start repeating, to do one complete cycle. Let's do another one. Okay, so here, again, you can start anywhere. Like even if you started here, from 3 pi, that's at the bottom of the wave, you would go all the way up, all the way down, and then once you get here, you have to start again. So from 3 pi to 9 pi, that's how long you needed to travel to complete one full cycle. So that's a distance of 6 pi. The period would be 6 pi. You also, if you started here from 0, when x equals 0, you would go down, and once you get here, you start repeating. Between 0 and this value, which is 6 pi, that's also an interval of 6 pi. So the period is a length. It is a length of time, a length of x values in which things start to repeat. And I wrote these 3 blue statements here. These you're going to have to feel comfortable with going in and out of when we do the next several problems. So they all involve what's the b value. The b value is when you put it into a function. And so let's just do an example. Okay, so the black function is just a parent function of sine, and I want to get the dashed function. And so this is my thinking. I first figure out what is the new midline. The original midline is y equals 0, right in the middle. Well, this new one is y equals -4. So the whole sine function had a vertical shift down of 4, down 4. And then once I figured that out, once I know where the middle is, I know how far up I need to go to get the top of the wave and how far down I need to go to get the bottom of the wave. And they should always be the same because you're in the middle. So from the middle to the top, you go up 1. And from the middle to the bottom, you go down 1. So that is the amplitude. The amplitude is 1. And if it were flipped upside down, notice how the original starts going up and then down, and so does the dash one. So that means the a value is positive, but if it started going down and then up, everything got flipped upside down, so this would just be a -1. And then this is where b would go. Now, b, when you have the graph, it's easiest to think of b like this middle one. B times the period equals 2 pi. So that's another way of saying however many cycles there are in 2 pi, that's what b is. So here's 2 pi right here. How many cycles do I need to travel through before I get to 2 pi? And in this case, it's just 1. So a full cycle, a full period is going up, down, and then back again. So that's 1 full cycle. And I landed exactly at 2 pi. So the b value is 1. Oh, then I have to press try. And then you get some positive reinforcement there. And if it matches perfectly, you're definitely right. Let's get level 3 that has some different periods. Okay, for this one. Let's figure out the b value first. Here's 2 pi. How many cycles do I have to go through before I hit 2 pi? Whatever that answer is, that's b. So let's see, if I up, down, that's 1 cycle. Up, down, that's a second cycle. 3 cycles just to get to pi. So that must mean there's another 3 cycles to get to 2 pi. So that's a total of 6 cycles. So B is 6. Now, it's worth pausing here for sure. The period of the dash one is only pi over 3. That's the period, pi over 3. If all you knew was the period, you could find B by this top equation. Just take 2 pi. I'm sorry, I forgot what I said, but if I meant to say, if you only know the period, you could find the B value by using this top. 2 pi is a number divided by the period. We know the period is pi over 3, and I've got, you're multiplying, you're dividing by a fraction. So you flip and multiply. So if I flip that, it becomes 3, it becomes 3 over pi. The 2 pi's cancel out, and I'm just left with 2 times 3, which is 6. So 2 pi divided by the period will equal B. In fact, all three of these equations equal the same thing. You can start anywhere and get the other two. If you started with the top one, you can multiply both sides by the period to get the second one. And if you start with the second one, you could divide both sides by B to get the third one. So they're all 3 identical to each other. But when you're given the entire graph, it's much easier to figure out B just by counting. There are literally 6 cycles by the time you get to 2 pi. So that's what the B value is. The midline is positive 1. And the amplitude, well, from the midline, you had to go up 1 only. And so therefore it's positive 1. Let's try another one. Okay, this is a good one to do. So this one, it's not so, oh no, I'm sorry. Okay, so the dashed line, the black one is just the regular cosine function. The dashed one has a midline of -2. So that's, I always like to start there, -2. And let me get rid of, how do I get rid of this? And then once I know the midline, the amplitude from the middle to either the top or the bottom of the wave, it does not matter. That's a distance of 2. So the amplitude is 2, and there was no flipping going on, so it's just the A value is positive 2. Now, what is the B value? B goes in here. B goes in here into the function. And B tells you how many cycles you go through before you get to 2 pi. And it's not so clear because 2 pi looks like it's about right here somewhere. And notice I need 12 pi just to do 1 whole cycle. So 2 pi looks like it's about right there. Well, how much of that blue wave, what fraction of that blue wave did I pass through by the time I hit to 2 pi? It looks like less than 1/4. I mean, it's really unclear. So we must have another method, and we've got these three things. Really, you just have to remember one of them, and then you could just work out the other 2. So let's just pick the middle one. It doesn't really matter. I know that the period of my target equation is 12 pi. I don't know B. So B times the period equals 2 pi. Now it's just a simple matter of dividing by 12 pi to solve for B. If you divide both sides by 12 pi, you get 1/6. So remember when we were looking, what fraction of this big cycle, what fraction of that cycle did I pass through by the time I get to 2 pi? 1/6 of a cycle. That is what B is. B is called the frequency. It's also, you could also think of it as the speed. So you're traveling 1/6 is you're traveling very slowly. It's going to take a long time for you to finish 1 full cycle.